KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In this class, we are going to discuss about coherent and incoherent addition of waves. Coherent and incoherent addition of waves. Okay, ma? In our last class, we learned what is Doppler effect, and along with that, two example problems we discussed. Now, in this class, our focus, our concentration is coherent and incoherent addition of waves. Okay, right. First of all, what is meant by coherent waves and what is meant by incoherent waves? What is meant by coherent waves and what is meant by incoherent waves? Okay. Afterwards, what is superposition principle? What is superposition principle? And then afterwards, what is meant by interference? So there itself, what is constructive interference and what is destructive interference? With this constructive interference and destructive interference, what happens in different situations? In different situations. So these are all we are going to discuss in this class. Okay, right. What is the application of this constructive interference and destructive interference means? Suppose for example, if we are going to drop two stones of having same size almost, right, at two different points on surface of water, then what will happen? The two different stones are going to produce two different waves. Then as time passes, the two different waves are going to superimpose on one another. Then you can see one pattern. Then you can see one different type of pattern, right? That is not like wave 1, that is not like wave 2. It is the combination of wave 1 and wave 2. That is the best example. So here I took water surface and throwing of stones as the situation to create two waves. Similarly, you can take two different light sources, right? Otherwise, you can take two sources of same, having no phase difference, okay, having some path difference. So with these different cases, right? Okay. So now we are going to see first what is meant by superposition because superposition is the base for interference. Superposition is the base for interference. Okay, right. Superposition principle. According to superposition principle, a particular point in the medium, right? According to superposition principle, the entire field of interference, right? You see here, observe carefully. The entire field of interference is based on the superposition principle, according to which at a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacements produced by each of the waves. So in this, to discuss interference is the one of the very important phenomena in our subject or in our daily life also. So for the interference, superposition principle is the base. What is superposition principle means? The resultant displacement produced by number of waves is the vector sum of the displacements produced by each of the waves. Next, we are going to see the pattern. how the interference pattern will take place and what happens when constructive interference and destructive interference takes place, etc. See here, consider two needles S1 and S2 moving periodically up and down in an identical fashion in a trough of water, right? They produce two water waves, and at a particular point, the phase difference between the displacements produced by each of the waves does not change with time. So this is like assumption also. So we have to consider this point, that is, the phase difference between the displacements produced by each of the waves does not change with time. When this happens, when there is no phase difference between the displacement produced by each of the waves, then the two waves are said to be coherent. I will repeat once again. When the two waves having no phase difference, then the two waves are said to be coherent waves. Suppose if there is phase difference, means those two waves are said to be non-coherent. Okay, right. For example, if you just imagine two waves are going to produced by two different sources, but phase difference is not there. So for coherence of waves, you can say that here, you know very well, wave means which consists of crest and trough. The phase difference between crest and trough is 180 degrees. Okay, and what is frequency, what is amplitude, what is intensity, what is wavelength, what is time period. These are all the properties of waves, right? So these are all the terminology related to waves that we discussed. Okay, right. Now we are going to see like derivation. So the condition we are going to derive for coherent sources of waves. Okay, right. So from the picture, I will show you the picture. So from the picture, you can write that S1P is equal to S2P. S1P is equal to S2P. Suppose it is S1 and it is S2, means this is the point P. So from here waves are going to generate, from here also waves are going to generate. The two waves are going to generate and they are going to move forward as like. Now this is the point, reference point we are going to take. So S1P and S2P, right? So in this moment, at this moment, here you can say that S1P is equal to S2P. Just imagine, S1P is equal to S2P means what? There is no path difference. Right? S1P is equal to S2P. Right? S1P is equal to S2P. Right? Okay. S1P is equal to S2P. Now, if the displacement produced by the source S1 at the point P, if the displacement produced by the source at the point P is given by, like, y1 is equal to a cos omega t. Y1 is equal to a cos omega t. Before writing this displacement for one wave, you just keep in mind S1P and S2P are equal. And the waves from S1 and S2 will take the same time to travel to the point P, and the waves that coming from S1 and S2 in phase to reach the point P while reaching the point P. Okay, right. Now we are going to write the displacement equation for one wave, that is y1 is equal to a cos omega t. Okay, and then we are going to write the displacement produced by another wave from source S2. It will be y2 is equal to a cos omega t. Right? Okay. Now we can write the resultant displacement at P now. That is y is equal to y1 plus y2, that is equal to 2a cos omega t. This is the resultant displacement of the two waves emanating from S1 and S2. Right? So it is 2a cos omega t. Okay. And you also know that if you go for intensity is directly proportional to the square of the amplitude. No. Intensity is directly proportional to the square of the amplitude, right? So I is directly proportional to a square. So here you can say that intensity of the resultant wave is equal to 4 into I naught. 4 into I naught. That is the intensity of the resultant wave. What is I naught here? I naught is the intensity produced by each one of the individual sources. Each one of the individual sources, and I naught is directly proportional to A square. I naught is directly proportional to A square. Okay, but the resultant wave intensity, the resultant wave of two different waves comes from S1 and S2 will be 4 I naught. Okay, here the two sources are said to be interfere constructively, and we have what is referred to as constructive interference. Constructive interference. Okay, here when y1 is a cos omega t and y2 is equal to also a cos omega t, right? Now we are going for another example. See here, we are going for another example. This is what it is S1, it is S2, it is Q. S1Q is equal to 7 lambda and S2Q is equal to 9 lambda. Okay, so here what happens? See this, the two waves, the waves emanating from S1 will arrive exactly 2 cycles, because 2 lambda is difference, no, 2 cycles earlier than the wave which comes from S2, but again will be in phase. Here also the phase difference is 0, again will be in phase, right? So now the displacement from the wave coming from S1 will be, it is a cos omega t, but the displacement, the wave which comes from y2 will be a cos omega t minus 4 pi, right? A cos omega t minus 4 pi. So according to the trigonometry, here a cos omega t will come. So y1 is equal to a cos omega t, y2 is also a cos omega t, right? So in between these two, y1 is equal to, in between these two, that is what S1Q and S2Q, the path difference is 2 lambda, phase difference is 4 pi. Keep in mind, the path difference is 2 lambda, phase difference is 4 pi. Okay, so the two displacements which comes from Q to S1 and the two displacement which comes from S1 and S2 are in phase, and the resultant intensity will be again 4 I naught. So which is also gives to which also gives a constructive interference, which also the example of constructive interference. Okay, but here S1Q and S2Q are much greater than D. So this is the D. So it is like S1, it is like S2, it is the distance between the two waves. So just this picture is showing that, for example, it is like if one is trough means the another one is crest, trough, crest, like that. So just now I told you, while starting this class, I told you when two waves are going to interfere, what happens and how the pattern will be. That you can experience from this picture. Okay, right. So after completion of that, what I am saying is, here if you observe carefully, the amplitude of the displacement produced by each of the wave, the amplitude of the displacement produced of the each of the wave nearly same. See here, it is what a cos omega t, it is also a cos omega t, right? Now we are going to take another example. This is one example. Here it's okay, it is constructive interference and the path difference is 2 lambda and phase difference is 4 pi. It's okay. Now we are going to take another example. It is what R, S1 R, S2 R, right? So now we are going to see, now we are going to apply the same procedure to discuss this situation. Here S2R minus S1R is equal to minus 2.5 lambda, minus 2.5 lambda. Okay, so here the difference, the path difference is 2.5 cycle between S1 and S2. Okay, here y1 is equal to a cos omega t, y1 is equal to a cos omega t, but y2 is equal to a cos omega t plus 5 pi, a cos omega t plus 5 pi. Then what will happen? It is minus a cos omega t, minus a cos omega t, right? So one is a cos omega t, another one is minus a cos omega t, right? So now if you observe carefully, the two displacements are now out of phase, and the two displacement will cancel out to give zero intensity, because the amplitude of the resultant wave is y is equal to y1 plus y2 now. So when it is a cos omega t plus of minus a cos omega t will give us zero displacement, right? So here you can say that the wave with zero displacement means it is the example of destructive interference, the example of destructive interference. Okay, here the path difference is 2.5 cycle difference, that is what 2.5 lambda, and phase difference will be 5 pi. So if you observe carefully, with this phase difference 5 pi, the crest will fall on the trough of second wave, and the trough of the first wave is fall on the crest of second wave, so that there may be a chance. So here it is sure. So when crest fall on trough and trough fall on crest belongs to two different waves coming from two different sources, then we are going to discuss about there is a chance for the arising of destructive interference. But in our example, as according to this example, it is damn sure it is here destructive interference takes place. Okay, right. But in our class, in this class, by taking different examples, right? So first y1 is equal to a cos omega t, y2 is equal to a cos omega t, and then by taking this one, here also we are getting same mathematically, and by taking this example we are in a discussion. So how the interference takes place, and whether it is constructive interference or destructive interference, and in case of anyone either constructive or destructive, what is the path difference, what is the phase difference, and in case of destructive, that is what second example here, this is what, right? So here also what is the path difference and what is the phase difference, that and all we are in a discussion. But now we are going to derive a general formula, like general relation, to get constructive interference or destructive interference. That will be like this, see here, right? So for two coherent sources, S1 and S2 vibrating in phase, then at a point P, S1P difference S2P. So this is the difference, see this, not this one, this one, S2P minus S1P. So here basically difference. So we are not sure about whether it is S2P minus S1P or S1 minus S2P. Just we are taking the difference between the path difference between S2P and S1P is equal to n lambda, Similarly, if you go for another side, that is what for destructive interference, S2P difference S1P is equal to n plus 1 by 2 into lambda, Here n is equal to 0, 1, 2, 3 dash 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 dash. Okay, so here it is the condition for destructive interference, it is the condition for constructive interference. These two conditions we came to write based on the discussion of many examples. So here we had 2 or 3 examples. So the first one is just like general thing, second one we took example, and third one also we took example to show destructive interference. Okay, right. So now what I am saying is, what about the resultant intensity in case of destructive interference? It will be 0, no? Resultant intensity will be 0, because the displacement, resultant displacement is also 0. So when displacement is 0, intensity is also 0. Okay, but in case of this, here the intensity, resultant intensity will be 4I0. So 4 times the intensity of any one of the wave. Okay, right. Okay, right. So till now whatever we discussed, it is just by assuming that, okay, when there is a phase difference, when there is no phase difference, see here, so what is meant by coherence, right? So one side we are in a discussion, but now what we are going to discuss is, suppose if there is any phase difference, right, what will happen, right? So this destructive interference and constructive interference also, here there is a phase difference, here it is 4 pi, here it is 5 pi, but see the situation, But see the situation, here it is 4 pi and here it is 5 pi. It is a general thing. Unlike that, suppose for example there is a phase difference of 5. So how to find the resultant displacement, right? So for example here I told you what is the resultant displacement, right? And this is constructive interference, this is the destructive interference. Based on these two we derived relation, conditions we derived. So if you remember these two conditions, you can easily find out what will happen. Similarly, we are going to derive a condition when there is a phase difference. See here, suppose if y1 is equal to a cos omega t, y2 is equal to a cos omega t plus phi, then what about y? It is y1 plus y2, no? It is y1 plus y2. It will be like this. So you have to apply some trigonometric formulas, that is cos a plus cos b. So cos a plus cos b is equal to 2 cos a plus b by 2 cos a minus b by 2. So here you can write 2a cos phi by 2 cos omega t plus phi by 2. So regarding this resultant wave, the amplitude is 2a cos phi by 2 and the intensity will be I is equal to, this is the intensity of resultant wave, it will be 4 I naught cos square phi by 2. 4 I naught cos square phi by 2, where phi is equal to 0, comma, plus or minus 2 pi, comma, plus or minus 4 pi, etc. Okay, right. And this is what when the phase is constant, when the phase difference is constant, between the two waves, that is what phi. In another case, right, suppose if the phase difference is changing continuously, what happens to the resultant wave's intensity? That is called as time average intensity distribution. I is equal to 4 I naught cos square phi by 2. Okay, when the phase difference is constant between the two waves, it's okay. Why? Because there you can expect a stable interference pattern, right? It's not the problem. But when the phase difference is changing with respect to time, then this is the expression for the intensity of the resultant wave. That will be 4 I naught cos square phi by 2. So the resultant intensity, right? So excluding that trigonometric function, if you are going to write the resultant intensity, it will be 2 I naught. Okay. So that is the situation when the phase difference between two waves is continuously changing with respect to time. Okay. So when the phase difference between the two vibrating sources changing continuously or rapidly with time, the two sources are said to be incoherent. When the phase difference is not changing with respect to time, it will be coherent. When the phase difference is changing rapidly with time, it is said to be non-coherent or incoherent. Okay. So when this incoherent types of waves you can experience means when the two sources are illuminate, when the two separate light sources. For example, one is tube light, another one is sodium light. Okay, there you can see non-coherence between the two waves which are coming from two different sources of light. Okay, so two different sources of light means you don't think that one is tube light, another one is sodium light. Both two tube lights also you can say that two different sources of light. Okay, because the sources will be different, no. But here you have to observe that here non-coherence means definitely, damn sure, one is tube light means another one is like sodium light. Okay, but here in our previous discussion when I was explaining all these things, I used two different sources of light means maybe both are, not maybe, same, both are tube lights only. This is tube light means this is also tube light. For example, this is the sodium light means this is also sodium light. But there is a path difference here. Here also there is a path difference. There is phase difference. But phase difference is not changing with the time. Because these are the coherent sources. S1, S2 or here S1, S2 are the coherent sources. But whereas if you come this point, here we took non-coherent sources. When there is non-coherent source, then it will be time average intensity distribution. This is the intensity of the resultant wave. Okay, so finally if you can write I is equal to 2 I naught. Okay, ma? Right. So in this class we focused to learn what is interference, what is constructive and destructive interference, what is the condition for constructive and destructive interference, what about the intensity of the resultant wave when the sources are non-coherent. Okay, so for the interference the basic thing is superposition principle. Afterwards we came to discuss many examples. Based on these examples we derived two conditions. Okay, afterwards we have written intensity for non-coherent, intensity for resultant wave of two waves coming from non-coherent sources also. Okay, thank you. We will continue in the next class.